we have two events, event A and event B. Event A has three outcomes, annotated as A1, A2, and A3. And event B has four outcomes, annotated as B1, B2, B3, and B4. The two events are not independent from each other. We can establish a joint probability table that gives a probability of each outcome of A with each outcome of B. So you can see on this table that the probability of A1 and B1 both occurring is 0.04. And the probability of B1 and A2 occurring, the joint probability there, is 0.09. We also are given in this problem that the total probability of B1 occurring is 0.16. Similarly, the probability of A1 and B2 is 0.06, B2 and A3 is 0.13, A2 and B3 is 0.02, A3 and B3 is 0.08, A1 and B4 is 0.14, A2 and B4 is 0.07, the probability of B4 is 0.30, the probability of A2 is 0.22. So we know the probability of B1 is 0.16, and the probability of A1 and B1 is 0.04, A2 and B1 is 0.09. We know that the probability of A3 and B1 has to be 0.05 in order for it to sum to 0.16. We know that the probability of A2 is 0.22. Hence, the probability of A2 and B2 has to be 0.04 in order that 0.09, 0.04, 0.02, 0.07 then sum to 0.22. Sum across the row for B2 to get the probability of event B2 occurring is 0.23. Because we know that the events are collectively exhaustive, which means the total probability of B of the four outcomes of B is going to be 1, we now know that the probability of B3 is going to be 0.31. As the total probability of B3 is 0.31, we know that the probability of A1 and B3, the joint probability there, should be 0.21. Joint probability of B4 and A3 should be 0.09. Down the columns to get the total probability of A1, which is now 0.45, and the total probability of A3, which is 0.33. We've now completed our joint probability table. As a quick check, you can see that all the numbers inside the cells sum up to 1. You can also see that if you go to the right-hand side, the total probability of all the events of B, B1, B2, B3, B4 sum to 1, as well as the probability of A1, A2, and A3 also sum to 1. So it looks like we did this correctly. This is a fun part where we can calculate out conditional probabilities based off our joint probability table. So the first problem we're going to look at is the probability of A2 given that B2 occurs. So we know that the joint probability of A2 and B2, pulled from the table, divided by the probability of B2 will give us this conditional probability. Values from the table, we know that the joint probability of A2 and B2 is 0.04, and the probability of B2 is 0.23. So this gives us the probability of A2 given B2 as being 0.174. Let's look at something a little more complicated. So let's look at the probability of A3 given not B3. So similar as before, we can write out this conditional probability as a joint probability divided by the total probability of not B3. We can expand this out. So the joint probability of A3 and not B3 is the same thing as the probability of A3, the joint probability of A3 and B1, the joint probability of A3 and B2, and the joint probability of A3 and B4, all of the B events that don't include B3. Similarly, the probability of not B3 is going to be 1 minus the probability of B3, or simply the probability of B1 plus B2 plus B4. Like before, we can just pull the value straight from the table, and you can see that we have a probability of 0.391.